video, I'm going to show you how to solve a system of equations by substitution. So let's start by just writing down the steps on how to do it. First things first, you want to isolate one variable. So when you're given a system of two equations, take one of the equations and get one of the variables alone. So you get to pick whichever equation you want to use. So go for the one that's with a variable that's easy to isolate. You're then going to substitute that variable or the value of that variable into the second equation. You're going to solve for that variable. Then lastly, once you solve for that variable, plug the value of that variable into the first original equation that you started with. So you can think of it like IRP. Isolate, replace, plug in. Alright, so let's just jump into an example. So 5x plus y equals 9. Then I also know that 10x minus 7y equals negative 18. So I'm going to isolate a variable. I'm going for this one because it's the easiest. It's almost alone. That's the y I'm going to go for. So 5x plus y equals 9. I can subtract 5x on both sides, which will give me y equals 9 minus 5x. So I isolate it. Next, I'm going to replace. So I'm going to take the fact that y equals 9 minus 5x, and I'm going to plug it into my second equation. So I get 10x minus 7 times 9 minus 5x equaling negative 18. I'm going to solve. So 10x minus 63 plus 35x equals negative 18. Combine, so I get 45x minus 63 equals negative 18. Add 63 on both sides. That gives me 45x equaling 45. Divide by 45 on both sides. So x must equal 1. Okay. So once I know x equals 1, I've isolated, I've replaced. Now I'm going to plug in. So now that I know that x equals 1, I'm going to take that 1 and plug it into this equation here. Y equals 9 minus 5 times 1. So y must equal 9 minus 5. Y must equal 4. Second example, 8x equals 2y and 2x plus 3y equals 42. So I'm going to pick a variable to isolate. So I got to pick a variable to go for. I'm going to go for, I think this y seems easy. So I get 8x equals 2y, so I'm going to isolate. That means I'm going to divide by 2 on both sides, so I get y equals 4x. I've isolated. Now I'm going to replace, so I'm going to take 4x and plug it in for y in the second equation. And solve for x, so I get 2x plus 12x equals 42, which is 14x equals 42. Dividing by 14, x must equal 3. So I've isolated, I've replaced, and now I'm just going to plug in the fact that I know x equals 3. So 4x equals y. 4 times 3 equals y. Y must be 12. And I forgot to mention, you want to make sure you write your solution as an ordered pair. So I'll put 12 over here and x equals 3 over here. So my final solution will be 3, 12. Alright, so let's do a few examples of where things don't work out as nicely. So negative 3x plus y equals negative 3. And y minus 3x minus 1 equals 0. If I were you, my first move would probably be to clean this up as much as possible. So I would go ahead and add 1 to both sides. just so that it looks a little more simpler, I would simplify. Simplifying early saves you work in the end. Let's go ahead and get a variable alone. I can just go ahead and add 3x if I want to. So y will equal 1 plus 3x. We've isolated. Now let's replace. Let's take that 1 plus 3x and plug it in for y. Negative 3x plus 1 plus 3x equals negative 3. Now what's going to happen here when I try to combine these two? They eliminate each other. So I'm just left with 1 equaling negative 3, which is not true. So this is an example of no solution. Alright, let's do this one. 2y equals 4x minus 6 and 4y plus 12 equals 8x. Maybe we'll go for this y. Seems easy to isolate. So 2y equals 4x minus 6. I'll divide everything by 2, leaving me with y equals 2x minus 3. Since y equals 2x minus 3, I'm going to plug it into my second equation. So I get 4 times 2x minus 3 plus 12 equals 8x, and I'm going to solve that out. So 8x minus 12 plus 12 equals 8x. Negative 12 plus 12 is 0, so I get 8x equaling 8x. See how I have the same thing on both sides? This lets me know that this solution has infinitely many solutions. This system has infinitely many solutions. Alright, let's do the word problem, then we're done. If Robert has 10 coins, all nickels and dimes worth 70 cents, how many of each kind of coin does he have? So that question at the end lets me know what my two variables are going to be. One has to represent the number of nickels, and I'll let y represent the number of dimes. So I know that he has 10 coins. This must mean x plus y equals 10. The number of nickels plus the number of dimes will equal the total of 10 coins. I also know that they're worth 70 cents. So that means 5 cents comes from each nickel I have, plus 10 cents comes from each dime I have, and that will equal the total of 70 cents. So those are the two equations I'm going to solve. Well, the system I'm going to solve. Isolate a variable. I'll go for x up here. So I'm going to subtract y on both sides. I get 10 equals x equals 10 minus y. Plug that into my second equation. 0.05 times 10 minus y plus 0.10 y equals 0.70. So I get 0.5 times 10, which is 0.50, minus 0.05y plus 0.10y equals 0.70. I can combine those two, right? I get a negative, wait, that's not negative. I get a 0.05y. Subtract my 50 cents on both sides. So 0.05y equals 20 cents. And when I divide that by 0.05, I should get a 4. So my y is 4, which means that's 4 dimes. So when I plug it back into my equation, I know that x must be 6. So I have 6 nickels and 4 dimes.